Peace, Emma. Now, for this unit, you will need a calculator every day. And you will need a calculator that can do the following: addition, subtraction, multiplication, division, square, and square root. You're going to need a calculator that can perform those 6 functions. If you're not familiar with square or square root, everybody has their first day where they get familiar with it. This is going to be yours. We all have our first day for everything, our first time for everything. All right. You do have a homework assignment today and tomorrow. They're both due by 11:59. Now, what I like to do is, this is not just me. A lot of people like to associate red with acids and blue for bases. So if we want to make your notes color coordinated, I'm going to be using red and blue a lot during this unit. If you have those colors, you're welcome to utilize those. Yeah.
For the people that have to say tomorrow, can I just look at the list online?
Yep. Okay, so you all have many household items that are acidic and basic. I'm going to try to show you a movie clip from something that's acidic and that is actually basic. When I was in school, here's what I thought. You know, like a lot of boys played Mortal Kombat. You got Reptile. Reptile spits on his enemy and he melts into a pile of goo and he spit acid on him. So I always thought acids are bad. They'll hurt you. They'll burn you. Bases are good. They kill the acid. Wrong. The acids are some acids can be very powerful. You have acids in your stomach. There's acids in batteries. But also, bases can be just as potent. Bases are things like drain cleaner. Think about that. They unclog drains. They break that stuff down. Sodium hydroxide is a very powerful base. It's also called lye, L-Y-E. It can melt your flesh. It's very nasty. So there's different types of substances, more or less drain cleaner, oven cleaner. We're going to talk about various substances that you can even find in your household that are acidic and basic, okay? But let's use red first. Some acids are things like vinegar, citric acid, pineapple juice, orange juice, grape juice, mango, and soda. When I was a summer camp counselor, when I was in high school, you know, I was just a summer job like any other high schooler. We had like a little science rotation, and I told the kids, find an earthworm and put it into a bottle of soda. And the next day it was gone because soda has phosphoric acid in it. When I was in college, my college roommate was a golfer, and he would clean his golf clubs with soda. It would break down rust. When I was in high school, I had a Jeep, and I had a leak in my car, and it kind of made the tailgate very rusty. And I said, Dad, I got rust in the back of my car. What am I going to do? He gave me a steel brush and a bottle of phosphoric acid. He said, here, scrub it away. So I poured some phosphoric acid on it, and it started to break down the rust. And I scrubbed it with a steel brush, and it all came off. You drink that. You drink soda, there's phosphoric acid in it. Not very good. And then you have stuff like battery acid, which can really ruin your day. So if you're ever carrying a car battery, those big blocks, hold it away from your body, because if you're swinging around when you're walking, it's sloshing everywhere. That is sulfuric acid, and that could really ruin your day. All right, some bases. Some bases include soap. Antacids, obviously that means anti-acid. Tums, Rolaids, Alka-Seltzer. We have baking soda. And cleaners, like I said earlier, oven cleaner, drain cleaner, those are all different bases. Yeah. Okay, other physical properties. Acids and bases can conduct electricity. They're made up of ions, so they kind of behave like electrolytes. Water is a non-conductor. Now, the reason that we use blue and red is because there's a test called the litmus paper test. Imagine that I had a cup of an unknown solvent, some sort of liquid that was in this cup. I dip litmus paper into that substance. If it turns red, it would indicate that it is acidic. If it turns blue, it would indicate that it is basic. Red color indicates acids. Blue color indicates bases. Now, I do want to indicate to all of you that another word for a base is called alkaline. If you ever hear the word alkaline, that means base. If you are trying to, if something is basic, that would also be called its alkalinity. All right, here we go. Let's get to the nitty-gritty. When it comes to acids, whenever you guys see one of the two following ions, your brain needs to go to acid, 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 acid. The first one is going to be a hydrogen ion. If you see H, especially H+, you need to immediately think, oh, that's an acid. Now, another suitable substitute to hydrogen, in fact, it's pretty much the same thing as hydrogen, is H3O with a positive 1 charge. This is called hydronium. You need to remember these names. Hydrogen ion and a hydronium ion. They're interchangeable. On a worksheet, you might be dealing with hydronium. On worksheet number 2, you might be dealing with hydrogen. Hear me now. They are the same thing. They're interchangeable. Yes, Nicole? Because they have a positive charge with hydrogen. If hydronium is simply water with the third hydrogen added to it, a hydrogen ion.
What about hydroxide? Isn't that?
We're getting there. But these are the same thing. Whenever you see these two ions, you need to think acid, acid, acid. Now, for a base, that's going to be a hydroxide ion, OH, with a negative 1 charge. Whenever you see hydroxide, 99 times out of 100, base, 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 base. Most bases end with the word hydroxide. Sodium hydroxide, lithium hydroxide, calcium hydroxide. Okay? All right. All water molecules contain hydrogen and hydroxide ions. Now, in the past, I told you guys that this is how you can make water. When I was in high school chemistry, this equation just really irritated me because I didn't understand balancing yet. The teacher would just do this. Ready? Remember this? I told you this. H2 and O2 yield H2O. All right, well, where did the other oxygen go? Well, it's not balanced. Now it is. That's what I've been teaching you before. Now, let me show you a new way to make water. This always stumps my AP Bio kids. Hydrogen ion reacts with the hydroxide ion. Tim, if you combine hydrogen and hydroxide, how many total hydrogens, like H's, are there? 2. And Kevin, how many oxygens are there? H2O, everybody. There it is. Hydrogen and hydroxide yields water. Yep. So Arshan has said the word neutral. There are 3 different titles that you can assign any given substance. It can be acidic, it can be basic, or it can be neutral. Okay? So this means the amount of hydrogen and hydroxide determines whether an aqueous solution is acidic, basic, what's the other word for basic? Alkaline, or here's your third option, neutral. I'm going to teach you all how to just look at something and know, oh, that's basic. Oh, that's neutral. That's acidic. That was easy. It actually is pretty easy. So, how do we tell? If something is acidic, how do you tell? Here's how you tell. The concentration of hydrogen exceeds the concentration of hydroxide. See those brackets I drew? You may want to write somewhere on the side. Those brackets mean concentration. And what is the unit of measurement for concentration? Molarity. Whenever you see those brackets, it means concentration. Moles per liter. If the moles of hydrogen per liter exceeds the moles of hydroxide per liter, it is an acid. If it is a base, then the moles of hydroxide exceed the moles of hydrogen. So what do you think it is if it's neutral? They are equal.
Are acids positively charged and bases negatively charged, or is that just?
No. A neutral substance is where the 2 concentrations are equal to each other. So I'm going to write that down. Neutral solutions contain equal concentrations of hydrogen and hydroxide. Yes?
Why is neutral like blue?
It's purple.
Oh.
All right. Are there any questions so far? You've got a lot of information taken in your brains. And, you know, the way the human brain works is you got to give it about 24 hours to really settle in there. So if it's a shock to your system, that's normal. All right, let's continue. Pure water molecules can self-destruct ionize to form, what is H3O called? Without looking at your notes, what is H3O? Hydronium. And what is OH? Hydroxide. So this is going to be your first example. This is going to help you more with tomorrow's homework. I want you guys to write H2O plus H2O. This symbol right there, notice I have arrows pointing in both directions. That means that this is a reversible reaction. The reaction can go forward or it can go backwards. Now, let's, I really want to break this down for you all so you can clearly see what I'm doing. So please try to pay attention to me. There's one water molecule. I'll make the oxygen black, the hydrogen's white. There's another one. Okay, now, you ready? Nick, what would happen if I took this hydrogen here and moved it, let's try it again. If I took this hydrogen here and brought it over there, what would that be now? It's just one oxygen and one hydrogen.
Hydroxide.
That would be hydroxide. So OH can be formed. And Colby, what is this guy here now with one oxygen and 3 hydrogens? H3O. What's it called? Hydronium. This is what we mean in that water can self-ionize. This is going to have a positive 1 charge, and this is going to have a negative 1 charge. Water can just self-ionize to form hydroxide and hydronium. Okay. Any questions yet, Nicole? It's just, it happens in water that you drink. It's just the natural flow of ions. It's called ionized water. You ever heard of DI water or distilled water? That's where it's not charged, and it doesn't do this. But when you have ionized water, it does this all the time. It just flows back and forth from water to the ions. Okay, now there are several models that recognize what is an acid and what is a base. There's 3 models. You guys have to know 2 of them. And the first one is called the Arrhenius Model. This is simply what makes an acid and what makes a base a base. Like what characteristics? This is actually a vocab term as well. So I'm going to change things up a little bit. I'm going to make your vocab terms in orange just to make them stand out. In this term, the Arrhenius Model, what time we get out of here? 10, 11, 10? Oh yeah, 19 minutes. An acid is a substance that contains hydrogen to produce hydrogen ions in aqueous solution. A base contains hydroxide ions in the same circumstance. Yes, Kevin.
So is the model the thing that portrays the acid as having this?
No, it's the model is indicating that any given substance Any substance that has hydrogen is considered an acid, and any substance that has hydroxide is considered a base. So here's an example. This is what your homework is more like tonight, all right?
Basically, OH or hydroxide ions to produce hydrogen ions.
Yeah, I think this visual is going to really help you out. So here is hydrochloric acid. Now, obviously, when I say that name, hydrochloric acid, you know it's an acid. But to the untrained eyes, you look at HCl, all you see is HCl. You may not know its name. But if you place this into water, it is going to form hydrogen ions, and it is going to form chloride ions. The fact that it produced hydrogen ions tells you what? It is an acid. If you place that into water, and as I said earlier, if it produces hydrogen or H plus ions, or for that matter, hydronium, same thing, it is an acid. Now later in this unit, you're going to learn how to name acids. This is hydrochloric acid. This is the acid in your stomach. If you've ever thrown up and your throat burns and your mouth burns, that's because you just puked up acid. Well, the reason why your stomach doesn't burn is that your stomach has a layer of mucus, which protects it from your acid. If you've ever heard of an ulcer is just an area of your stomach that does not have the mucus lining, and the acid actually burns a hole into your stomach. So that's bad. But your throat and your mouth do not have this mucus lining, which is why they're exposed and they can burn whenever you puke. Now, take a look at this substance. That is called sodium hydroxide, also known as lye. It can be drain cleaner. It's very powerful. If you place it into a bucket of water, you're going to get a sodium ion, and you're going to get a hydroxide ion. And the fact that hydroxide was produced tells you what? It is a base. Alert, alert, alert. It's a base, it's a base, it's a base, it's a base. Yeah.
So what's the full name of the second part of base contains OH ions?
If you place it in, it's a substance that contains OH, and if you place it into water, it will produce OH ions, separated from the compound. So this is known as dissociation, everybody. This is what your homework is like tonight. All you have to do is just really do some decomposition reactions. This is known as dissociation. If Arshawn and Nicole are friends and then they're going to just shun each other for the rest of their lives, they have dissociated. They're no longer associating themselves with each other. Dissociation means they're separated, they're no longer involved.
Is it like the ionization constant from last evening?
In a way, you could say the ionization constant would be 2 for both of them. Are there any questions with the Arrhenius model? All you need to know is that if you have a substance and it contains hydrogen and you place it into water and hydrogen ions are released, it's an acid. If you have a substance that has hydroxide, OH, and you place it into water and OH ions come off of it, it is a base. That's it. Yes? No. Nope. All right, let's do the other model that you will be responsible for. The Bronsted-Lowry model. In this model, again, vocab term, an acid is a hydrogen ion donor. It is giving hydrogen. A base is a hydrogen ion acceptor. Okay. So here is a demonstration. If you're giving hydrogen, you're an acid. If you're receiving the hydrogen, you are a base. So here is just a generic example. Now this one, I think you guys, this is going to lead me to your homework tomorrow. This will actually be our last page for today, so we're not in a super rush. We can spend 12 minutes on this if we have to. If you guys prove to me that you are getting it, we can move on to tomorrow's lesson, but this is really the end of today's lesson. I want you just to focus on, here's how I like to think of it, before and after. All right, that's it, before and after. This is HX. What is X? X is just a variable, it doesn't matter. So this is before, remember this is the reactant side. This is the product side. Products come after, reactants come before. Kendall, this is HX. That's the before image. Which of the two products on the right would have been the after? H3O or X? Yeah. So Kendall, here's my question. What changed? You go from here to here. What changed about it? Okay, here it's HX on the left, and on the right it's just X. What happened to the hydrogen? How would you simply describe it? Okay. I was hoping you would say it lost it. Okay? The hydrogen was lost. Can you all see that? You go from HX to just X. It lost it. Well, another word you could think of is it donated it. Lost, donation, gave it, whatever verb you want to use. The fact that HX has H here and no longer has it here means that it gave it away. What does that tell you about HX? Is that an acid or a base?
Acid.
Why? It donated it. Well, Kendall was getting to it. Kendall, where did that hydrogen go? It went to the H2O. So what is H plus H2O? H3O. If you want to see that, here it is. H plus H2O. Emma, what would that be? H3O. That would be H3O. Don't forget the positive charge. That's hydronium. So what does that tell you about the water? The water accepted that hydrogen. That's the base. It can be both. It just depends on what's happening in every problem. Water can be an acid or a base. It just depends on a case-by-case basis. On this example, water is a base. This is according to the Bronsted Lowry model. It's simply the hydrogen ion acceptor. That is the definition. Yeah.
So does that make water neutral?
Don't worry about the pH. You're saying neutral by P. That has to do with pH values, and we're not there yet. So just based on this definition, water is water is a base, not because of its neutrality or its pH level. By definition, it accepted the hydrogen ion. By definition. That's all it means. The questions that you're asking are things we have not gone over yet. So your brains are going to places that we haven't done, which is going to lead to confusion. So just focus on this right here, right now. Your questions will be answered. This is a very sophisticated unit. And we're only on day one. I think things will get cleared up a lot this week. But by the sheer fact that water accepted the hydrogen to go from H2O to become H3O, that means that H2O is the base. Okay? Now, I'm going to ask you all, and I want you to be honest, are there any questions with any of that? Arshan?
Can't
But like acids and bases can exist without each other. So it's like you're defining them to.
There's conjugates, which is going to get me to our next topic. You have to think of the conjugate acids and bases. You ever heard of those?
No.
All right. Nicole?
So does there have to be an acid and a base in the reactants that we're using for?
It depends which model you're referring to. In this model, yes. In the Arrhenius model, no. In the Arrhenius model, you don't have to have both. In the Bronsted Lowry model, you do.
How do you know which one is?
Because if you look at that model, that's just a simple decomposition reaction.
Okay.
One reactant, multiple products. Here, it's a double replacement. Now, I'm going to delve into a little bit of tomorrow's lesson, okay? I want you guys to go from right to left. Try to read backwards. If X is just by itself, poor little x, and it goes from here to here, it gains a hydrogen. What does that mean?
That makes it.
Reverse the arrows. You go from here to there. Colby, what is the difference between X and HX just by the letters used, the elements used? The H. Okay. So Colby, it went from having no H to getting an H. Does that mean it donated an H or it received an H? It received it. What does that make X?
Base.
Now, because it is on the right side of this equation, we call this the conjugate base. Well, matter cannot be created or destroyed. It has to cycle. Hydrogen ions just go back and forth, back and forth, back and forth. And where did that hydrogen ion come from? You can't just have hydrogen ion go, poof, came out of the thin air. That'll drive us all crazy. What else on the reactant side, or excuse me, what else on the product side has hydrogen? Francis, the hydronium, it has 3 of them. Well, I want you, and again, this is your first day. I understand. Some of you might be a little lost, so it'll be better tomorrow. Hydronium has 3 hydrogens. Do you see that? How many hydrogens does HX have? 1. So how many hydrogens did hydronium give up to have X become HX? 1. So now that hydronium, H3O, lost 1 hydrogen, what is it now going to be? It's going to be H2O, and there it is. So hydronium gave up a hydrogen ion. It donated it. What does that make hydronium?
Conjugate acid.
It is the conjugate acid.
But it's not a reversible equation. Does that not matter?
It's not a reversible equation. The way that conjugates work, and this is where we're going to finish off today, because I want to deal with a lot of this tomorrow. Guys, follow me here. The acid, when I was asking Kendall, before and after, the acid will always form the conjugate base. Whatever's left. HX formed X, that's the conjugate, or that's the acid formed the conjugate base, and the base will always form the conjugate acid every time. Every time, no exceptions. The acid on the left is the conjugate base on the right, and the base on the left is the conjugate acid on the right. We'll do a lot of practice with conjugates tomorrow. That's your homework for tomorrow. That's really most of tomorrow's lesson. So I think that tomorrow's going to be a full day. No homerooms, no fire drills, none of that stuff. We'll get a lot of work in there, and I'm hoping in our 49 minutes tomorrow, you'll really get a good idea of how this works. So this is to be continued.